Use Kramer's rule to solve the system. 2x plus 3y plus z equals 2. 3x plus 3y minus z equals 0. X minus 2y minus 3z equals 1. We're going to begin by finding a determinant that we're going to label D. It's going to be a determinant made up of the coefficients in each of our equations. So for our first row, we're going to have 2, 3, 1. In our second row, we'll have 3, 3, negative 1. Third row, 1, negative 2, negative 3. Let's go ahead and evaluate this determinant. So D will equal, and let's review how to evaluate determinants. We're going to start with our top row. We're going to take the value of 2. We're going to multiply that times the value that we come up with if we're working with a determinant where we erase the column and the row that value is in. So in other words, we're going to be looking at this 2 multiplied times the determinant, 3, negative 1 in our top row, negative 2, negative 3 in our second row. Then going along our top row, we're going to put down minus, because we're going to alternate in signs. This was a positive 2. This will be a minus 3. Multiplied times the determinant that we come up with when we take out the row and the column that value was in. So we're going to end up with, on our top row for our 2 by 2 determinant, 3, negative 1. And we're going to end up with the 1 and the negative 3 in our bottom row. Then, again, going across our top row, we end up with a plus sign in front of the 1, multiplied times a 2 by 2 determinant, again created by erasing the row and the column that value was in. So we'll end up with the determinant that has a 3 and a 3 in the top row, and a 1 and a negative 2 in the bottom row. Now let's continue evaluating. D will equal the value of 2 multiplied times the value of this 2 by 2 determinant. To evaluate the 2 by 2 determinant, recall that we're going to multiply across the diagonal that goes from the upper left to the lower right. So that product is going to give us a negative 9. And then we're going to have minus the value that we come up with when we're looking at the diagonal that goes from the upper right to the lower left. So that product is going to give us a 2, so we're going to subtract 2. Let's do the same thing for the next determinant. We're going to have 3 multiplied times negative 3, that's negative 9, minus 1 times negative 1, which is negative 1, so subtracting a negative 1 is the same as adding 1, plus 1 multiplied times 3 times negative 2 is negative 6, minus 1 times 3, which is 3. So D is going to equal 2 times negative 11 minus 3 times negative 8 plus 1 times negative 9. That gives us a value, D equals negative 22 plus 24 minus 9. And that's going to be 2 minus 9, which is going to give us a value of negative 7. So our value for D equals negative 7. Now, if we're looking to solve for the variable x, we're going to come up with a ratio where we're going to have D sub x, that is a determinant with related to the value x, divided by D, which was the coefficient determinant that we just found out. Let's see how we create D sub x. To create D sub x, we're going to have a 3 by 3 determinant where we're going to take our values that came from our x's and we're going to replace those values with our constant values in the equations. So our new determinant is going to have in its first column the values 2, 0, 1. We're going to keep the other two columns exactly the same. So we'll have the 3, the negative 2, and we'll have 1, negative 1, negative 3. Now we need to evaluate this determinant. So our D sub x is going to equal the value of 2 in our first row times the 2 by 2 determinant where we take away the row and the column where the 2 appeared. So we'll have the 3, negative 1, negative 2, negative 3. Minus, we'll take our second entry on our top row, that's a 3, Multiply that times the 2 by 2 determinant that comes from what happens when we erase that row and column. So we'll have our 0, negative 1, and we'll have the 1, negative 3. Plus, we'll take our value of 1 multiplied times the determinant that we'll get here when we take away the top row and the third column. So we'll have 0, 3, 1, negative 2. Now let's evaluate this. D sub x will equal 2 multiplied times, we'll have a negative 9 minus a positive 2 minus 3 multiplied times, going along our diagonal, 0 minus a negative 1, which is going to be the same as plus 1, plus 1 multiplied times 0 minus our product of 3. D sub x then equals 2 times negative 11 minus 3 times 1 plus 1 times negative 3. D sub x equals negative 22 minus 3 minus 3. That's going to be negative 22 minus 3, which is negative 25, minus another 3, which is going to give us a value of negative 28 for our d sub x. Let's take that value, and we're going to now solve for our value of x by substituting our negative 28 for the numerator, and the value of d that we found out earlier from our coefficient determinant was negative 7. And that gives us our x value of positive 4. Now we're going to look for our y value. To find our y value, we'll have a determinant labeled d sub y divided by the coefficient determinant d. To form d sub y, we're going to take our coefficient determinant, and where we have our y coefficients, we're going to replace those with the constants. So our first column will be the same, be 2, 3, 1. Our second column will be replaced with 2, 0, 1. Our third column will remain the same, 1, negative 3. Let's now evaluate this determinant. We'll have d sub y equals the value of 2 times the 2 by 2 determinant, 0, negative 1, 1, negative 3. Minus, we'll take the next entry on the first row, that's a 2, times the determinant, which is going to be formed by, again, taking out the row and the column. So we'll have 3, negative 1, 1, negative 3, plus our last entry, 1, times the 2 by 2 determinant, 3, 0, and 1, 1. Let's evaluate d sub y. This is going to be 2 times, we'll get the product here, which is 0 minus a negative 1. That's going to be 0 plus 1. Minus 2 times, we'll have 3 times negative 3, which is negative 9, minus a negative 1, which is going to be plus 1, plus 1 times 3 times 1, which is 3, minus the product, which is 0. D sub y then equals 2 times 1 minus, we'll have 2 times negative 8 plus 1 times 3. This gives us d sub y equals 2 plus 16 plus 3. And that ends up giving us 18 plus 3, which is going to be 21. Let's now take this value for d sub y and substitute back into our equation. Here we have y equals the value of d sub y, which is 21, divided by the previous value of d that we found, which was negative 7, to give us the value of y equals negative 3. Now we're going to look for the variable z. To get our value for z, we're going to take a determinant matrix, sub z, divided by our coefficient matrix d. Let's look at how to form d sub z. Well, like what we did for d sub x and d sub y, we're going to take our coefficient matrix and replace the column where we had our z coefficients with our constants. So our first column remains 2, 3, 1. Our second column remains 3, 3, negative 2. Our third column becomes 2, 0, 1. Let's now evaluate d sub z. It's going to equal our entry of 2 times the 2 by 2 matrix, 3, 0 in the top row, negative 2, 1 in the bottom row, minus the value of 3 times the 2 by 2 matrix where we'll have 3, 0 in the top row. We'll have 1, 1 in the bottom row. And we'll end up with plus the value of 2 times the 2 by 2 matrix where we have 3, 3 in the top row, 1, negative 2 in the bottom row. So d sub z will equal 2 times, using our products, we'll have 3 minus 0 minus 3 times, we'll have 3 minus 0 plus 2 times, we'll have negative 6 minus 3. So d sub z equals 2 times 3 minus 3 times 3 plus 2 times negative 9. D sub z then equals 6 minus our value of 9 minus a value of 18. So this is going to be a negative 3 minus 18, which gives us our d sub z equals negative 21. Let's now take this value and substitute to find z. Z then equals the value of d sub z, which is negative 21, divided by our previously found result for d of negative 7 to give us our answer for z equals 3. So to summarize, we've determined that our x value equals 4, our y value equals negative 3, and our z value equals positive 3. That's going to give us the ordered triple 4, negative 3, 3 as the solution to this system. We can say that's our solution set.